For 14 years, Arthur Cayley worked as a lawyer in London. In his spare time, evenings, weekends, holidays, he wrote over 300 mathematical papers. Then Cambridge finally offered him a professorship. He took a massive pay cut, and he kept producing 967 papers by his death, covering nearly every branch of mathematics. Part 8. The Victorians. Arthur Cayley, born 1821, died 1895. The Quiet Giant. Last time we met James Joseph Sylvester, the word maker who invented matrix, discriminant, and invariant. We saw his struggles with discrimination and his eventual triumph at Johns Hopkins and Oxford. Welcome back to Men of Mathematics. Today we meet Sylvester's partner, Arthur Cayley, who produced mathematics as effortlessly as breathing. Together, they created the algebra of matrices and invariant theory. Alone, Cayley founded group theory in its modern form and explored geometry in any number of dimensions. Our learning objectives today: understand the abstract definition of a group, see the Cayley-Hamilton theorem, discover how quiet productivity transformed mathematics. Arthur Cayley was born in Richmond, England, in 1821. At Cambridge, he was senior wrangler, top of the mathematical tripos, and won the Smith's Prize. Unlike Sylvester, being Anglican, he received his degree. But Cambridge had no suitable position for him. The mathematical establishment was small, and professorships were rare. Rather than languish in a minor position, Cayley trained as a lawyer. For 14 years, he practiced conveyancing, the legal work of property transfer. His evenings and weekends belonged to mathematics. In those 14 years, he wrote over 300 papers. In 1863, Cambridge created the Sadlerian Chair of Pure Mathematics. Cayley was appointed. His salary dropped dramatically from his legal income. "I never hesitated," he said. Cayley gave the first abstract definition of a group, a set with an operation satisfying closure, associativity, identity, and inverses. This abstraction freed group theory from specific examples and allowed the general theory to develop. Cayleys Theorem states, every group is isomorphic to a subgroup of some permutation group. This means studying abstract groups reduces to studying symmetries of sets. It's a foundational result in algebra. With Sylvester, Cayley developed matrix algebra. He showed that matrices satisfy their own characteristic equations, the Cayley-Hamilton theorem. If A is a matrix with characteristic polynomial P of lambda, then P of A equals 0. This fundamental theorem appears in every linear algebra course. Cayley explored geometry in 4, 5, or any number of dimensions. To him, n-dimensional space was simply n coordinates obeying certain rules. This abstraction, radical for its time, is now routine in physics and data science. Cayley helped found algebraic geometry, the study of geometric objects defined by polynomial equations. His work on cubic surfaces revealed that a smooth cubic surface contains exactly 27 lines. He also studied quartic curves, finding that a smooth quartic has exactly 28 betangent lines. Cayley's collected works fill 13 volumes with 967 papers. He wrote on algebra, geometry, analysis, combinatorics, mechanics, nearly every mathematical topic of his era. He never seemed to struggle. Ideas flowed continuously. Where Sylvester was flamboyant, Cayley was calm. Where Sylvester fought and struggled, Cayley worked steadily. Yet they were friends and collaborators for decades. Sylvester described Cayley's mathematics. Cayley is forging the weapons while I am trying to use them. Cayley's abstractions, groups without specific elements, spaces of any dimension, matrices as objects in themselves, shaped how mathematicians think. The Cayley-Hamilton theorem appears in every linear algebra course. Cayley graphs represent groups visually. His ideas pervade the field. Arthur Cayley produced 967 papers while working as a lawyer and later as Cambridge professor. He defined abstract groups, developed matrix theory with Sylvester, explored higher dimensional geometry, and helped found algebraic geometry. He did it all quietly, without drama, as naturally as breathing. When asked how he did it, Cayley had no answer. The mathematics simply came. As E.T. Bell wrote, "Cayley probably is the only mathematician who ever lived who could work with equal ease and success in any department of mathematics." Next time on Men of Mathematics, we meet Carl Weierstrass, the late bloomer who became the father of modern analysis. He spent his 30s as a school teacher in obscurity. Then his paper on abelian functions astonished the mathematical world, and everything changed. Thank you for joining us on this journey through mathematical history. If you're inspired by the quiet productivity of Cayley, subscribe and hit the notification bell. New episodes release every week. I'll see you next time.